Hello, everyone. Welcome. I'm introducing Carissa Twele from Fluid Life, and she's going to be talking on ISO IEC 17025 quality systems in the laboratory. So I'm going to hand this over, and so Carissa will take over here.
I won't show your screen. Okay. I won't show your video. Oh, okay. Sounds good. I'm from Fluid Life. I'm a quality manager at Fluid Life. I have a little slide. She clicked off of it. 1 second. There you go. Laboratory quality manager at Fluid Life. I started at Fluid Life in 2010 as a lab technician, and then I moved my way up into the quality system, and now I am the quality manager of Fluid Life. So any quality related questions that ever come through to Fluid Life, that would go to me. And so this is a basic overview of the ISO 17025 standard. There's a lot of parts to the standard. It's just a very basic overview. Can't give all the secrets away because it is a copyrighted document, but I will do my best to kind of give you guys an overview of what that looks like in the lab and what it takes to become an accredited lab like Fluid Life. So I'm sure a lot of you guys have heard of ISO 9001. It's a very general standard. So as a difference between ISO 9001 and ISO 17025 is that 17025 encompasses all of 9001, and then there's the lab component on top of that. So if you are ISO 17025, you are also theoretically accredited to ISO 9001 because it is a portion of 17025. You just don't get the certificate saying that you're 9001. You can. It is part of the standard that, you know, if you are 9001 accredited, you don't have to go through the last portion of that standard when you're being assessed. They just kind of do a few checks. But if you have your certificate as 9001, then you don't need to do that portion of the assessment. So as I was saying before, it's a very general standard for 9001. A lot of manufacturing companies will have this standard, mostly about documentation and making sure that you're logging your non-conformances. 17025 encompasses 9001. So how is ISO 17025 typically applied in a laboratory? For most labs, it'll be utilized with the objective to improve the quality's consistently valid results. So if you're looking for a lab, somebody that is 17025, you can ensure that they have the ability to give you consistently valid results. Because when you're looking at your oil analysis program, if you get 10 ppm of silicon one day, and then 2 the other day, and then 20 the next day, and you're wondering if it's valid or not, if it's 17025, chances are there is some sort of quality program to ensure the validity of results by QC checks and calibrations and all that great stuff, which we'll go through a little bit after. And the overall goal is to continue to improve the effectiveness of the management system. Quality shouldn't be an obstacle to overcome. It should be something that enhances your day-to-day processes in the lab. And if it's done right and you can do it seamlessly, then the lab technicians and other people that work for you barely notice it. It's just part of the day-to-day. So how does accreditation benefit a laboratory? Well, from our perspective, it's a point of reference to make sure that we are giving out good data. If we don't have a point of reference, then how do we know that that is 10 ppm silicon? It allows the lab to determine if they are performing the work correctly. So a higher confidence at the bench level is very important too. So a technician will be doing a test at the bench level. If their QC is passing and they're all quality control checks pass, then they can be confident that the results they're reporting that are going to go out to the customer are correct. In turn, that benefits us because it generally gives us greater customer satisfaction. And then we identifies and drives continuing improvement. I was saying before, for business processes, operations testing, customer service, it all helps drive that for us to ensure that our customers are happy. So what does it mean to be accredited to our customers? So as I was saying before, the standards and procedures specifically developed determine technical competence. The data and the results provide accurate and reliable, and how that's accomplished is through all of these things that I listed. We're going to go a little bit through it during the presentation. So you need facilities, methods, equipment, proper quality control, traceability, document control, all that stuff. And then we'll go through that a little bit. So the basics. So ISO 17025 is many pages. They have many shall statements. Anything that says shall in these statements for ISO IEC means that you must. You don't have a choice. So there's quite a few, but the way the lab meets that criteria can be different. So one lab might decide they're going to put it in writing, in a procedure, in a log, and then another lab might decide they're going to put the procedure in the log, but it's going to be electronic or something like that, depending on how your lab is made. So as an example here, this is an excerpt from ISO 17025. It says records shall be retained for equipment which can influence laboratory activities. The record shall include the following where applicable. So identify the equipment, the software, and the firmware version. So you can do a logbook, paper log, you can do an Excel spreadsheet, you can have something in your quality manual, you can do many different things as long as that criteria is satisfied that ISO 17025 is telling us to do. The good thing about ISO 17025 is that the new one, it was in 2017, the old one was very prescriptive. It would say you need a quality manual, you need a quality manager, and you need this. Now it's a little bit more open-ended so that the labs have a little bit more freedom to choose how they implement these shall statements in their procedures. So it's 5 basic parts: general requirements, structural requirements, resources, processes, and management requirements. We'll go through each one of these a little bit. One is that work must be completed impartially. So anytime that we are coming up with processes within the lab, you want to have impartiality, safeguarding impartiality in mind always. The lab must show in some way that they're committed to impartiality. And again, you can do that in many different ways. You can write it down, or you can have meetings all the time to show that, you know, we're looking at this and we're making sure we're safeguarding any different ways. Any risk to impartiality must be identified on an ongoing basis. So if you have any risks to impartiality, relationships or activities or anything like that, you must list them on an ongoing basis and be able to show that to your assessment officer. Confidentiality, this is not just a legal issue, is also part of the ISO 17025. All customer information must remain confidential, and there's extra little excerpts in there about what happens if you're legally enforced to provide results. That doesn't really happen in our industry because we're not a regulated industry, but something like drinking water and stuff like that. There's also other governmental implications that, you know, they put things in the standard to ensure the customer's confidentiality as much as possible. If they are going to be shared in the public domain, it must be communicated to the customer before that happens. And it's clearly written in the standard. So that's very basic overview of the general requirements. There's a few other things like you have to be a legal company and all that great stuff, but skipped over that one. Structural requirements. There must be evidence of a person that has overall responsibility of the lab. So you can have the person that's responsible for your lab as the same person as the quality manager. So I theoretically could be the lab manager plus the quality manager, but I have to be impartial on both ends. So if I'm the lab manager, I can't just send out data because the customer is waiting for it. If I think there's a quality issue, if I think the results aren't valid and I want to check those results to ensure they're correct, I have to be impartial as much as possible. I can be the same person, but I also have to have quality in mind. And, you know, at Fluid Life, we have many different hierarchical structures to ensure that all that impartiality is in place. It's one of the easiest ways to do it. But again, you can have a one-person lab and still maintain the standard, but you'll have to have processes in place to ensure your impartiality in that respect. There also must be documentation for all your procedures. So the easiest way to do that is have like a handbook, a quality manual of some sort. You list all of the stuff that you say you do in your labs. So for the overall quality system is the easiest way to do it. So you can find it in one place and there you go. But you can, again, you can do logs, you can do individual SOPs for each test and list over and over and over again the same stuff. But, you know, it depends on the lab, how they want to meet that, that criteria. The newest version of the ISO 17025 removed the requirement of the quality manual. So in the older version, they said you must have a quality manual. There was no interpretation there. But now you don't need one if you can prove that you don't need one, and you can implement all of your quality system or document it some way or somehow without having that sole handbook. And the lab must also define their range of activities. So when you look on somebody's website, they might say we're ISO 17025 accredited, but that may just apply to a certain scope. So they might have 30 tests, but they might only be accredited to 3, depending, because each appendices does cost you extra money when you're getting accredited. You know, being accredited does cost some money. So they might choose only 10, or they might choose all of them. It depends. Sometimes if it's a lab that is a government regulated type testing, you have to be accredited. You don't have a choice. For our industry and tribology, generally it's, you know, just good for the customers to know that you can get good results if you have an accredited lab. It's not yet a requirement in any way, shape, or form, but it's the best way to ensure, again, that our customers are getting good results. So resource requirements. So this one's a little bit of the longer one. Personnel. You must have competence requirements such as education and work. So when you're hiring people, you're looking at their resumes and they must meet certain criteria. That criteria has to be outlined in some way that this is what you're looking for when you're looking to hire somebody. So it could be the spectrum of a diploma to a degree to a master's degree, a PhD, whatever you decide. All staff must be trained and their proficiency must be evaluated on an ongoing basis. So you can use a training form, a log, electronic log, you can do different ways, but you must show that you are evaluating their effectiveness ongoing. So you have to do it throughout the year, and that also can be accomplished by reviews, performance reviews as well. Records of their training and ongoing evaluations must be maintained, again, either electronically or paper copy. Facilities. I don't know if any of you guys have been to our building, but you do have to have an appropriate facility, and incompatible testing should not be mixed depending on what you're doing. Again, in our industry, we don't really have a lot of that, but for some labs that might be doing microbiology versus, I don't know, let's think here, microbiology with, you know, tribology, let's say they're doing both, you're not going to do both in the same section or building, possibly depending on what kind of testing it is. They're probably not compatible. Also, you know, you shouldn't have your coffee, you know, area in your microbiology room. That's probably really not a good idea. Stuff like that, little things like that. So you know, they do ensure that the facilities and the environment are appropriate for the testing. And an assessment officer can tell you to literally pick up your equipment and move it if it's not compatible. Equipment, this is a requirement that you have to validate all of your instrumentation before it's being used. So you do that with standards. That's an example of a TAN titrator. So we'll load all that guy up, run it, make sure it passes the criteria that we expect. That might be through ASTM standards. They might say you need to pass this criteria, or it might be our own criteria depending on the situation. And in a government lab, it's going to be their criteria, most likely what they need to pass. And so all instrumentation is checked, always. Traceability. I don't know if you guys have heard of traceability, but it's part of the standard as well. My little picture is kind of small, but it kind of shows how it works. You have the highest standard at the very top, and as you descend the ladder of basically perpetuating traceability, your measurement of uncertainty is going to get wider and wider and wider. So as a really kind of a good example is like if you have calipers or a measuring instrument of some sort, you know, you can get it calibrated at the highest level, you send it straight to the source and you're going to get the greatest calibration ever. But is that actually necessary for your applications depending on what you're doing? So you might opt for, you know, something a little bit down the rung, but your uncertainty is going to be greater. So if you measure with those calipers, you know, whatever to 1,000 or millimeters, and, you know, you get, let's say, like, I don't know, 1,000, let's say, that might be plus minus 500. Or if you've got the perfect one, it might be plus minus 10, depending on what you're getting. So the biggest thing about traceability is that all uncertainties must be propagated from the highest standard down. So if you have, like you have a standard and it says, this is this uncertainty. So, you know, your calipers, it's like, you know, 10,000, let's say, and you go down and you get the next one, that uncertainty is propagated to the next one because you can measure each again. So it's kind of like making a ruler. If you have a ruler in some safe somewhere, and that's the golden standard of rulers, you make your ruler to that standard where you're never going to quite make it exactly the same. If any of you guys are in machining, you're going to have some sort of tolerance of some sort. So it's going to be maybe a little smaller. It's going to have uncertainty. And so you take that second ruler and you make your third ruler, fourth ruler, fifth ruler, that uncertainty is going to get larger. And it may, you know, 1 centimeter might be, you know, 1.5 by the time you get all the way down, but it has to be all documented through traceability. Does that make sense? It's a harder concept for some people to get, but it's kind of laid out for you when you're doing quality. All right, process requirements, contract reviews. So if you ever engage in a contract with an analysis lab in general, usually you're going to go through some sort of tenders, contracts, RFPs, or just agreements, quotes, stuff like that. All of that counts as contracts, but the biggest thing is contract review. If you're signing a large contract, the lab has basically last say, so to speak, on whether we can do that testing. Depending on the situation, it could be that we just don't even have the equipment, but the customer wants us to do this test. Well, okay, but it's going to take us a year to get this up and running because we have to buy the equipment, we have to validate everything, we have to make sure everything is accurate, and then maybe we can provide you with that test. And then also, let's say you guys are going to send us, you know, 10,000 samples in a month or 100,000 samples in a month. We might need way more equipment than we have. So it might be a very simple request. However, you know, the capacity might not be there depending on the situation. And lab must inform the customer as well if they think a test requested isn't appropriate. So you ask for a certain test on a certain oil and we don't think that it's appropriate and you're basically wasting your money because you're getting no value out of it. The lab is supposed to let you know that it's inappropriate. Method validations. So this is what requires for when you're getting your equipment up and running. You have a method to follow and you need to prove each one of these. So accuracy, precision, method blank performance, method detection, linearity, analytical range, robustness. So accuracy is basically how accurate are you to the target. Precision is that if you run one after the other, how close are those together and from the target. Method blank performance is if you're expecting something to be 0. Is it 0? Is it not 0? Because that does happen sometimes depending on the equipment that you're using. Method detection limit. So that goes hand in hand with your blank. So if you run a very low level sample and you're thinking it should be 1 ppm and it comes back at 2 ppm, well, you run multiples of those samples, you might get a range of 2 ppm. That is the lowest we can go. Otherwise, it's just noise and it's not accurate results. Linearity. So you have a 0.0 to 1,000, anything in between. It could go off the path of linearity. So for certain tests that have calibration, you need to prove linearity. And then if it's not linear, then that basically you would have to, what's the best thing? Like you would have to tell the customer, 10% is the linear range, and then anything after that, your recovery may be 80%, depending on how big, or we just say, you know what, we can only measure up to 10%, depending on what the test is. And some tests just have that limitation because, normally it might be, we might be measuring around 2 ppm, but the customer requires up to 1,000 ppm. The test might not be linear all the way up to there, and you might get 800 ppm. You still have an idea if that element is there, but it's not necessarily an accurate result, and we're required to let you guys know that if that's the case. Analytical range, again, that's very similar. What's your top end? Can you measure up to 100%? Most testing, no, usually you have a top end of some sort. Robustness, that is just, so let's say you could shake something by hand, or you could put it on a mechanical shaker. Does that change the test result? So can you just give it a good quick shake and then put it onto the instrument, or does it need a mechanical shaker for 20 minutes? So robustness, you go through a bunch of permutations to determine whether you need to do those. So all of these things need to be done before you even start sending samples or testing samples for your customers. Make sense so far? All right, sampling. In our industry, we don't sample a lot for our customers. Customers send it to us, but a laboratory in tribology, like I said, it's not very common, but it would be common in places where the chain of custody is very, very important. So something like a forensics lab, chain of custody is extremely important. They can be accredited to ISO 17025 as well as some other standards, but that then they would need to be the one taking the sample, because you need to prove that you took it and it's in good hands from beginning to end. It's not really the case in our industry. Technical records, all of them need to be maintained. So you have to keep them. And for us, we're accredited by CALA. They say 2 years and a little bit, basically to cover an entire assessment cycle. So most accreditation bodies about 2 years, but it could be 3, it could be 1, depending on what you're doing. Uncertainty. So I was talking about uncertainty in terms of traceability. The tests that we generate also have an uncertainty. No test result is going to be 100% the same every time. So you test the sample once and you test it again. It might be a few ppm different. And when you're measuring the uncertainty, what you're measuring is the range of the true value, as it says here, the range of possible values within which the true value of the measurement lies. So you're going to have 10 ppm, and we might say the uncertainty is, 5%. So it's plus minus 5% of 10 ppm. And so when you're looking at your results, if you have a limit of, let's say you have a limit of 15, and I say it's plus minus 5%, you have to decide whether it is okay to go on, because you may be at your top end, and you may be past that end, but you also might be at the lower end. So you might be at the minus 5%. So, which one is it? When you're very close to whatever standard that you're trying to meet, depending on the situation. If, OEM says this is your limit, and you take uncertainty into account, you may fall below it, or you may fall above it, depending. Sometimes your true value is way above it, so then uncertainty doesn't even matter. So sometimes you need to make a decision depending on what the uncertainty of the test is. And the uncertainty has to be available to the customer. A little bit from now, we'll talk a little bit about reporting. We can report test results on a report without the uncertainty, but it must always be available to the customer. So if you called us up and you say, I want the uncertainty for a test, or you would call Oscar, you tell them, I would like the uncertainty so I can make a decision. We're happy to give that to you. And you can take a look at the results in that view, because 10 ppm is never just 10 ppm. Right, ensuring the validity of the results on ongoing basis. So first we validate all the equipment. We have to make sure, you know what, it is good to use. But after that, you have to monitor its performance periodically. Some labs will do it once a week. Some of them will do it once a month, depending on what you're running, because some testing is very involved and you can only do it once a week, every 2 weeks or a month. In our lab, oils are readily available. So we use QC oils that are in the industry to use as our QC oils. And so we do it, depending on the test, every 10 to 14 samples. So it's a lot of QC. We do quite a bit of QC. It doesn't mean that a lab that doesn't do it that often are no good. They're still maintaining the standard. It's just easier for us to have confidence that the results that we're sending out to our customers are accurate because we do so many QCs. And we don't report anything that has a failed QC. You are, as another lab, a different type of lab, might send out some results and it'll say on your report the QC failed in this case, but they're deeming it to be acceptable because like the standard allows for that. You're allowed to do that. And it doesn't make it wrong or right or anything like that, but it might say the QC failed. So then, you know, you would have a decision to make. In the case of Fluid Life, we don't. It passes. We're going to send it off to the customer. Just makes the automated processes that we have in place a lot easier for us to do it that way. Uncertainty calculations of the method must be available to the customer, as I said before. Proficiency testing. I don't know if you guys ever heard of proficiency testing, but this is another thing to ensure the validity of the results. We send out external PT to a company, an ASTM company, and there's all sorts of other customers around North America that have the exact same sample. They test it. We send in all our results via portal, and then they give us a Z-score. So it's usually kind of a normal distribution, and they tell you if you're within 3 Z-scores or out 3 Z-scores. So then if you're out of 3 Z-scores, you might have to take a look at your results depending on the situation to ensure that you're maintaining your proficiency, because what this is telling you that your validity of your results may be compromised at that time of running the sample, and it's something that you must correct. Alternatively, if there's no PT for your test, you can do interlab samples. So you compare other labs, or you do duplicates, or you do something to ensure that you're ongoing PT throughout the year. So reporting, there are numerous requirements, theoretical requirements for reporting. Section's about 3 pages long. It's probably one of the longest sections. You can put so many things. Your report probably could be 50-page long if you put all of that in a report. It wouldn't be a nice bird's eye view of the report itself, but it'd have everything in it. However, the standard does have a clause that says if the customer agrees to an abbreviated format, usually during the contract process is where that happens. If they agree to it, then we can send out an abbreviated format instead of giving you uncertainty, method detection, the method blanks, all those things I listed earlier, that literally would be in your report one by one. And your samples would be just, say 5 pages, 1 sample, 5 pages. It'd take forever for a lot of us in this industry. So we choose abbreviated format, and a lot of companies will. Oh, one thing that it said there is that one requirement is that anything that is changed. So if we send out a result to you guys and it is not right and quality discovers this, we're required to say that it's an amendment on your report. So you'll have a different version, and there's also a little symbol to say this is the test that it was amended, and then a reason for the amendment of some sort. There's usually some sort of comment to say why that result was amended. That is absolutely a requirement. That's outside of the abbreviated report clause. So if your report is ever amended or your result is, they must disclose the reason of why that is, either in a report or by email or some way, shape, or form. Non-conforming work. So in our lab or in any lab, a lot of that comes down to if the work satisfies our customer obligations. So we said to our customers, this is what you're getting for whatever it might be. And if we fail to meet those standards that we've said that this is what we're going to provide to you, then we would log it as a non-conformance. Any other serious and valid customer complaints, we need to log it and we investigate. And if a documented procedure is not followed. So those are the things that we see as non-conforming work, but it can be so many different things. You know, the procedure wasn't followed at the bench level. You know, like we sent out the wrong kits, we did this, or like there's so many things that, and everything is logged because you're required to log non-conformances. A lot of us just use it as a continuous improvement thing, not to be perceived as negative, to say you did something wrong. What we're striving to do is to do better next time by logging it and seeing trends or anything else, we can do better next time. And that's the bottom part, opportunity for improvement. So if you want to increase profits, reduce costs, accelerating innovation, you can also log opportunities for improvement as well. Control of data. So most laboratories will have some sort of LIMS of some sort, some sort of interface where all of their data goes into. That must be protected, and that also needs to be backed up should anything happen or fail. So a big server of some sort, it needs to be protected in some way and backed up. And that is a requirement of the standard. Okay, management requirements. So these are the 9001 requirements so that I was talking about earlier. So document control, approval, and issue. So document control means revisions, dates, I'll say it right down, and who authorized it. Generally, that's kind of how you would control the document, to say, you know, if somebody else is using a different revision, then you'll know it because it says on there that this is the ones, and you have a special place for the controlled documents, usually electronically, and to ensure that nobody is circulating something that is out of date. Sorry, control of records. So that's also very similar to document control. That there is just, you know, I control quality documents and I keep them somewhere, and we're going to ensure that nobody is distributing the wrong one. It's very, very similar, but it's a little different in that it's not saying you need your path on the document itself, it's where it's kept. Risk, all identified risks are considered and addressed. So most, this is a new part of ISO 17025 when they came out with 2017. Risk was in there because most labs will have some sort of risk assessment for a bunch of stuff. So when I was talking about that failed QC and they might still report that result to you, they're taking a risk assessment of whether that result is correct or not. And they have a process to ensure that, you know, they feel confident that even though that QC failed, that result is still accurate. The standard, again, allows them to do that because it's part of the risk assessment that they can take, saying that this is still valid. Okay, continuing improvement, preventative action, corrective actions. A lot of these are similar. It goes back to the non-conforming work. So non-conforming work can be at the bench level. It can be the whole quality system. They're talking here about the quality system itself. So is there something that, you know, in the quality system that we should be doing, such as, I don't know, training records, or we don't have educational requirements for a quality manager. So it doesn't say anywhere what your quality manager education should have. So therefore that would be a non-conformance and we need to fix it. That's basically the difference there. Internal audits every year. We're required to do an internal audit of the quality system. So that's the overall quality system. And then each lab is going to have appendices. So like I said, some labs might have 30 of them. Some of them might have 10. So a lab that has a lot of appendices to audit might choose to do, you know, 15 one year and 15 another, as long as they do all of them within that 2-year cycle that I was talking about earlier. CALA requires that anyways, depending again on who you're accredited with. SEC, I think, is a little bit more stringent on some things, they might require something a little bit different. Management reviews. So every year, top management, so vice president of labs or president, director of labs, whomever might be top management in that lab, sits down with quality and they review the quality system. That is a requirement, and there are very specific things written out in the standard saying you need to talk about this. There's like a whole list of things, and you must complete it every year, and you must show your assessor the last 2 years of that review that you've done with top management. You have to say who's attended, all that great stuff, and it's a requirement to do that. So you can have you can know that top management, if they are accredited, 17025 top management is generally committed to this quality system to ensure that our customers are getting valid results. Great. In closing, as I was saying, to become accredited lab, we need all of these things in place before you're even sending samples out the door. So document workflows and procedures. So we call those SOPs, standard operating procedures. Training, implement all aspects of the quality system, whatever that may or may not entail. Method validations and certainty calculations, and you have to do some proficiency testing before you are accredited as well. So for us, the quality provides a backbone for laboratory processes, drives efficiency, consistent and continuing improvement, and accreditation is a way for our customers to identify technical competence, which assures our customers that the results provided are accurate and reliable. So that's just a recap of what I'm saying, that, you know, you guys can, anybody that is accredited, you can feel sure that your results are valid. Any questions? I think that's it. Comments? I know it's a lot. The thing is really, really long, so I tried to make it as short as possible for you guys. It's a topic that's not too riveting. Any questions? Comments?
How long does a sample usually sit in the lab before you send out the results?
Well, are you talking about us or in general?
Yeah.
Well, we have a mandate for turnaround, and it would be in somebody's contract of how long it would take depending on the type of test. So every test is different, but the sample itself is, as soon as it gets to our lab, it's off to the races. It goes to setup, it goes into the lab the day of. Now, how long the test takes is a different story. So some tests take 7 days, some tests take, you know, literally, I don't know, 15 minutes. It really depends on the test. Yeah. And some of them have a holding time of 3 hours before they could, because they need to, the chemical reaction has to set in before we can actually test whatever we're trying to measure. So it really, really depends. And then again, if you're doing environmental or you're doing something else, it could be a completely different story because they have different standards for that, or yeah, ASTM standards or whatnot. So,
the process begins within 24 hours of receiving the sample.
Yeah, we have well, at Fluid Life we have procedures. It's literally laid out in our procedures. So if we get samples before, I have to remind me, 11 samples before 11, off to the races, and you can get those in, you know, I think it's a couple days now. But if you get it after 11, it may go into tomorrow's run, depending on how many samples we have. So we do have a cutoff time. You also have the option of getting a rush. So that rush cutoff time is 2. There you go. Sorry. I don't do it every day, so it's 2 o'clock. Yeah, Sarah's the director. Aaron's the lab supervisor. So yeah, so 2 o'clock. So if you send in a rush sample before 2, we'll try to our very best to get it out within about 3 hours. But again, that depends on the test that you choose. So
typical engine oil sample, you could receive results back within a day or longer?
What next day is usually, because the testing's all done. So you know, we have a workflow, so it goes through one instrument, then the next, then the next, then the next. So each one of those might take, let's say, half hour. Let's say, so by the time you're all done, it's, you know, end of day, and then somebody reviews your results before they go out. It's called processing in our lab. And so somebody's reviewing them to ensure there's no crazy results of some sort. That's an extra check that we do on top of the quality control that's on the bench, to ensure that the results are as accurate as we can, as we can make them. So yeah, so our goal is always about next day. But again, like, it depends on the test that you're getting. Could be the next day after that. And especially if we have to rerun a test, there is a test that takes about 3 hours for the reaction to take hold. And so if we have to redo that, you're looking at, 6 hours if the QC fails or something like that. So there are some limitations sometimes, but we do our very best to get them out.
You mentioned audits, but not specifically external audits. How often would you get an external person come in to do audits?
So that's the assessment cycle that I was talking about. So they don't call them audits anymore. They call them assessments. I don't know why, but so that's a 2-year cycle for CALA. We're accredited by the Canadian Accreditation Lab for Accreditation. Yeah. But again, that might be different for other accrediting bodies and depending on the type of testing you're doing. Yeah. So the standard does not specifically say what that audit cycle is, but it is up to the accreditation body, who have their own accreditation body to basically follow. They have their own standard. So because if they are accrediting us, they are adherent to whatever standard is their standard. So they also are audited as well regularly.
How do you determine how much gasoline to use to fill?
Diesel fuel.
And
So-
how do you use it?
Yep. So we have a gas chromatography, and what we do is we take gasoline, we put it into 15W40, or common oil that a customer might be making, as our standard, and we calibrate the instrument to be linear, as I was saying earlier. So we measure all the way down to 0 up to 15% approximately, because we are making them by hand. So it's, sometimes 16%. Put it onto the instrument, and that tells the instrument what 0 is, what 2 is, 3 is, 4 is, because we have multiple ones, 9 standards approximately. And we say, okay, this is 15%. So by calibrating that instrument with actual diesel fuel that you guys are using and in very similar oil, like a 15W40 of some sort, the instrument knows then what 15 and what 0 is. And so we also have intermediate quality control checks, and we measure that around 5%. And so at the beginning of a run, we'll say, okay, QC, we'll run all of your samples, and then a QC. And then if those are within the range that the QC's 5%, then it'll tell us what those results are. And it could be 10, 15, but because we calibrated the instrument to be to a linearity standard, it knows based on that procedure. Yeah. So it all has to do with method validation before, as I was talking before we even use the instrument. We have to do all those things, and then we can analyze your samples to tell you what that number might be. Yeah.
You still do distillation curves?
We do. We have an automated distillation apparatus now. We used to do it, and we have a manual and an automated one, but the automated one is just a little bit better. Here in Edmonton, we have one. Yeah.
What volume do you use?
Sarah, 100 mils. Yeah.
What's the normal volume?
Yeah. Or in one of those gasoline or dairy, those things.
Yeah, yeah, even if it's like filled to the top, still.
Fuel, yeah, we sell fuel. Yeah, fuel and actual fuel
Does it
container.
feel wild?
Yeah.
There's fuel.
Yeah, and they should be shipped in that because it's fuel and it's safer and all that good stuff too.
Well, they're usually about a gallon in size. It's the fuel sample cans.
Yeah, they're bigger.
We sell 1 liter fuel cans.
There you go.
Yeah. What about, do you have a test method for depth in diesel fuel?
Diesel exhaust.
Yeah.
Yeah, we have percent urea.
Yeah, we have a limited DF capabilities, mainly percent urea, and like sample count analysis, but we have some labs that we can outsource
Oh, okay.
that kind of concept too. Specifically if you're looking for depth in diesel, we have a lot that we can do.
They don't
We
make
take
well.
care of it.
And,
Yeah, it hasn't been a super commonly asked for test for us yet, so we haven't looked at doing it in-house yet, but there are some labs that we can outsource. outsource to, and as part of the quality system, we assess those labs as well to make sure they're reporting correctly and that, so you can ensure your results.
It's part of the standard too. Anything that we outsource to, we have to ensure they are also technically competent. And if it's an accredited test, such as GC fuel, so what we call it GC fuel, but diesel fuel and oil by GC, we're required to send it to an accredited. It has to be ISO 17025. Full stop. There's no choice. Yeah.
Would you say that overall that the technology that goes into the equipment that performs the testing, is it always getting better and advancing?
Yeah.
Can you always buy new equipment that is more accurate, requires less calibrations, has a faster cleaning cycle?
Yes and no. It depends on what it is. It depends on the test, for ICP, for your elements, your wear elements and stuff. The technology has changed quite a bit. Like before, it used to be an actual detector that detected visible light and UV light, because the way it measures it is by light. But now it's all cameras and they're like that big instead of being that big and that big. So it does change. And the way the electrons follow the path and stuff is not the same anymore. It just kind of, there's still mirrors and all that great stuff, but it goes to a camera. And so it's a lot different than it used to be. A lot of the ignition and the way the sample goes into the plasma is very similar, but the detection portion is the same. GC, I don't feel like it's changed a lot. Curtis is better with GC than I have and has been using them a lot more. I don't feel like it's changed a lot over the years. Yeah.
Is continually improved. Instrument manufacturers, they have a stake in wanting to make it better and better to try and sell it to labs with tighter detection rates, provided they're willing to pay for it.
Yeah.
Innovations.
Yeah.
But to answer your question, yes.
Yeah. They are. Yeah. For the most part. But again, it depends on what the lab is. It depends on what the customer needs, right? If the customer just needs to know if they have water or not, Crackle might be the way to go. You can literally put it on a hot plate and say, yep, you've got water. Or you can do KF titration and it'll give you a more accurate measurement. That is something that we do. You can get KF very accurate and Crackle, which tells you you do have water, but we don't know how much exactly. For example, that's, one way to look at it as well. A lot of that technology and the principles of those chemical reactions are very similar. Any other questions? No?
That's very good.
Thanks.
Thank you very much, Carissa. Excellent job. Thank you everyone for coming. We do have a screen here. So thank you everyone for coming. Our next meeting is in January and it will be in Calgary. We're looking, it might be at the same facility as it was for our last meeting. We'll see if we can come up with kind of a little bit of a partnership with them to use their facility. And it sounded like it was quite nice. I was not there, but those of you who were, so sounds like it was quite nice there.
Nice. Yeah, beautiful facility.
So if we can continue to use the facility, that would be awesome. So our next meeting, I can't think what day it's on right now. It is on a Monday. I think it's the third week in January. Third Monday. Okay. So if you have any questions, you can definitely come to any one of us, part of the executive. As always, if you'd like to join the executive, we would do